I'm Dave McAllister. Thanks for joining me. And by the way, thanks for letting me come here and talk about some new technologies that are coming and how it's going to probably affect you. So we're going to talk about WebAssembly. First of all, let me point out that I do work for a company called NGINX, which is part of F5. I am an open source technologist. I focus on where the world is going to be in the future. And we're going to talk about this thing called WebAssembly. I suspect a few of y'all have probably heard of NGINX. And we're going to cover that a little bit more as we get into this a bit. But first, this is a new wave of computing. The world is changing the way we've treated our applications, especially when we deliver them. And we started off in the long old days, not that long ago, I guess, 2000s, when we were having applications that ran on virtual machines. And from there, we started moving into the container worlds, we got into Kubernetes worlds, and then we started getting into this JavaScript running applications in browsers. And about the same point in time where that started really taking off, this thing called WebAssembly came out. And WebAssembly actually started with this failed attempt to do what was called a transpiler, compile from C and C++ to something that could run in your web browser. Well, what's happened is that in about 2017, every major browser included the WebAssembly capability as part of the browser. This is poised to become the next generation of technology that is going to deliver your applications on the web, it's already there, but also on the server and the back end. So what is WebAssembly? Well, WebAssembly is really think of it as a virtual CPU, not as a container, not as a system, but as a virtual CPU. And WebAssembly is the language that lets you compile down to that virtual CPU, which means things run really fast and things run really well. And by the way, it's not language dependent. And just to add to that, by the way, WebAssembly is one of the major standards that's supported by the W3C. It is a standard, and that's why all these companies that you're seeing in this list are supporting WebAssembly. Come on, wake up, wake up. Whoops, one too many, I think. There we go. So a couple of places that use them. Figma. Figma uses this to bring desktop experiences. Basically, they have a lot of C++ code. And that C++ code got translated into WASM, WebAssembly here. And they saw a 3 times improvement in going from JavaScript to WebAssembly. This runs in the browser. It runs in native performance on the browser. And then, sorry, the thing does not like me. Adobe. I worked for Adobe for 8 years. I can flat out tell you that Adobe's Photoshop is not the best piece of code. It's old. It's got a lot of pieces in there. And when they took Photoshop and put it into WebAssembly, it ran at about 90% of the speed of the native application. By the way, that's when it got my attention, is when I saw what WebAssembly was capable of doing for an application as complex as Photoshop and bringing it to the web in a performant manner. So those two companies are just examples. There's lots of others. Disney uses this. You are probably touching WebAssembly every time you touch a browser these days. But the problem is browsers are great, but that's not where the real work gets done. It's beyond the browser. And so we started looking at how we can move this to the next step, the server-side WebAssembly. So WebAssembly actually brings into being a couple of really interesting points. And the reason why it's so popular. First of all, it is a secure runtime. It is what's called fully sandboxed. You cannot get any access in or out of WebAssembly unless it's explicitly granted. WebAssembly actually only understands numbers. It doesn't understand strings. It doesn't understand any of those other things. It just understands numbers. And because of that, It can't do little things like even ask for what the system time is. It's also a single block of memory, so it's very easy to look for things that go beyond memory limits. So out of memory constraints are not possible in a WebAssembly environment. It has universal portability. WASM code runs on whatever the system is. If it's x86, if it's ARM, if it's something else, WebAssembly will run on that system. It's the virtual CPU, not the underlying CPU. And because of that, you only write things once. In our modern world, we have lots of different things that are running on different CPUs now. WebAssembly says, write it once, run it once. Been promised a lot, been promised for decades. WebAssembly is making that happen. It also is optimized for speed and constraint. Speed is very near to NGINX's heart. In 2002, NGINX actually started with the concept of saying, how do we make the web more performant? How do we make more connections happen in a server, web server? So speed is actually really important to us. And therefore, it has compiler optimizations, just like any other good compiler does when it's building your code. WebAssembly has the ability to do that. And it can deliver just-in-time compilations. It can also deliver ahead-of-time compilations. It's small, it's compact. It has all those advantages that are available to it. And what's now happened is that this thing, which started in 2014, is now mature and ready for real time. I swear I pushed the button. I did. Okay. Now watch, it goes one step too far. So WebAssembly starts in milliseconds. As fast as you can load the code down, WebAssembly is ready to run. And therefore, it can actually decode and run before the JavaScript actually gets parsed. This means that it is one of the fastest delivery mechanisms to deliver new code out to your environment to run in here. We talked about security sandbox. I told you I pushed one too many. We talked about security sandbox. That security sandbox means that it's not, come on, thank you. One more back, one more back. Come on, the other way. Okay. So not only is it highly portable, WebAssembly actually is supported by almost every language. Every major language already compiles to WebAssembly. If it's not there now, it will be. And this is something that changes the nature because you no longer have to have specific languages. You can actually write in to each of these things. These things are tiny. These things are really small, which means delivery is really fast. So what happens is that WebAssembly is actually this virtual CPU, which means it's actually executed by a runtime environment. And I mentioned interpreted just-in-time, ahead-of-time compilations. But there are certain things that are better for certain things. There are lots of runtimes available to a WebAssembly world right now, and they fit certain use cases better. WASM time is probably one of the most popular ones, but there are special purpose ones like what is called WASM 4, which is actually a WebAssembly runtime built for building retro games on, or something called Lunatic, which is designed for fault-tolerant work in a WebAssembly world. So if the slides will cooperate, we'll go to the runtime environments. Thank you for this. So here's some of the runtimes that are available. And you can see that some of these run in the browsers. V8, SpiderMonkey, WebKit, those are all in the browser. Every browser, every major browser has a WebAssembly runtime today. You can write and run WebAssembly code without even changing your work environments for this. But then we have the server-side world, and that's where we think things are really going to get interesting. WASM time is one of the big ones. Spin from Fermyon is one of the big ones that are there. WASM 3, if you're in a small environment, you're going to be running on a Pi, you're going to be running on something really tiny. WASM 3 is tiny itself and lets you run there. There are lots of one-time assemblies. They keep getting faster, and they keep getting more and more stable. So, by the way, I am trying to outguess this thing. It's not necessarily working. And when I push it once, it pushes twice. Sometimes I push it twice, it pushes once. So, JavaScript and WebAssembly feel like they're competitors. They actually aren't. Right now, today, if you want to do some interesting things outside of the WebAssembly environment, you're working in a JavaScript environment. And this is literally how to add two numbers together using WebAssembly through JavaScript. You're going to do the loads, you're going to do a fetch, you're going to call the module, the WebAssembly module, and then you're going to tell it to add two numbers together. In a runtime, it looks like this. It's a single line. WASM time is going to execute the WASM module directly. There is no other work that's necessary. I would sing and dance, but you don't want to see me sing or dance. So remember all that cool stuff I told you about how secure it is and how it doesn't know anything about strings and how you can't talk to the system? Well, that makes life a little challenging. And so what happened was this thing called WASI, or the WebAssembly System Interface. And WASI's been in development for a while now. We're now at what's called WASI Preview 2, with WASI Preview 3 coming forward. And it defines a standard set of host interfaces that are language independent, that allows us to talk to the outside world. And Preview 1 included command line, argument passing, environmental variables, clocks, those type of things. Preview 2 added HTTP capability to it so that you can actually start going from a server side and talk to the web. All built on this thing called a component model. And the component model is what's going to change the way we deliver applications. And Preview 3, which is currently being discussed, will add async and stream capability. So WASI is going to be the thing that enables this server-side world to actually happen. And this is an example of something in environmental variables. You can tell what's happening is that you're going to get the environmental variables, you're going to get the arguments, and you're going to do the command forward. So WASI simply defines the way that we can actually talk to systems in a memory-safe, sandboxed manner. WebAssembly modules, by the way, also can't talk to each other. They each have their own unique virtual CPU and their own unique solid, singular, linear memory space. And so if I want to talk two modules together, I have to use another mechanism to handshake across them. So I've got to use a network call, or I've got to use gRPC. And then all I can do is really hand off the pointer to the block of memory that I wanted to execute. And so it became a really bit of a pain. And so what WASI did was also redefine how we could start passing things from module to module. That module, interestingly enough, is actually not used a lot. End users never see WASI. It would be like expecting an end user to see the memory management inside of the Windows system or the Linux system. And those things allow us to simply build this thing. We have a libc call, which uses WASI in place of the usual system calls. So you can still do the system calls, but they're in such a manner that they are going to be in that sandbox, in the linear memory, in a secure environment, even though the language that's supporting them may not be a memory-safe environment. So WASI starts bringing all these interesting pieces together to allow us to build them. And again, keep in mind, you write this once and it runs on anything. So with that, one of the things that was built was this thing called a component model. And a component model allows us to make sure that memory remains safe. Memory is what's called composability. We actually can now put the memories so that they know how to talk to each other without each one interfering with themselves. And that memory representation is by type. And so the types that are defined for WASI are the only types that can be passed. And that goes into this canonical binary interface, or how we actually talk between these two. The nice thing is that it's completely language independent. The languages that are supporting WebAssembly support WASI and support the canonical API all at the same point in time, which means I can now write anything I want to, any module I want to, and anything I want, and be completely assured that they can talk together. There is no memory conflicts, there is no typing conflicts, there is no correlation conflicts. They will talk together in a WebAssembly world. This makes life a lot simpler when you've already got a module that exists and you're going to decide that it's going to talk to something else. WebAssembly, write it into it, you're pretty much assured that they're going to talk correctly. There we go. So this is the component model. The component model actually goes way back. It used to be really tightly coupled. Computers used to basically run the application. There was a single operating system. There were lots of libraries. We went through hypervisors. We went into kernels, into Docker. There's a great quote that the founder of Docker basically says, if WASI had existed 10 years ago, we wouldn't have Docker because we wouldn't need it. And then we ended up with, how do we control these stupid things? And that's where Kubernetes came into place. And then we started going into this WebAssembly world, where it was really very much a service provider. When we get into components now, it's anything. It can be on the edge and talk to the central. It can be anywhere you want to, at any time, any cloud, including your own. The advantages to this is that, once again, you can now, from a development and delivery viewpoint, work on your desktop and deliver the exact same environment into a cloud. You can build it locally and scale as much as you want to in a cloud level environment. Components make this possible for us to start building these very complex, very intricate application spaces while making use of all the pieces that we've already existed. So the data type is something called with WIT, which is WebAssembly Interface Type, or I believe that's right, I'm not sure. And it's a format that actually describes the inputs and exports, what we bring in and what gets sent out to a component. That components don't share memory. Remember me making the statement that memory is single-threaded, or not single-threaded, is a single linear block, and they do not share that memory space. This continues to make things memory safe. In fact, with WebAssembly, you can actually, once again, write in a non-safe language. The memory safe capability is because we know what the bounds are, and we can actually literally check the bounds at every given thing. So there are two things. There's what's called a low-level WASM type, something that's already existed and never done this. And then we can lift it and make it into a component model. Very straightforward, very simple model. We can actually also go the other way and take that high-level model and drop it down into a low-level WebAssembly type for that. As long as they adhere to the canonical ABI, they can be lifted. So that conversion means that things that already exist can now suddenly move into and become part of the WebAssembly component family. If you've already written WebAssembly, you're still going to be playing a part in this game. So NGINX is quite interested in this, especially when we got to WASI. That little thing called WASI does HTTP fits right into our wheelhouse. And so we started looking at this and saying, what makes sense for WebAssembly when it comes to the NGINX world? And two places come out. Building application functions that live on the edge so that they're closer to the end user environment, as well as building custom plugins that work no matter what the environment is. Those two pieces make the best sense for us. Since we are open source by nature and open source by root, we have both projects and products that are involved there. And I'm going to introduce you to one of those pieces. something called NGINX unit. Most of you are probably familiar with NGINX, the WebAssembly, web server, reverse proxy, caching server, etc. We actually have about 80 different open source projects right now. In the public, NGINX unit came out, interestingly enough, about 2017. And it is an application server that has lots of native application runtimes for various languages. And we added WebAssembly to it because we see that WebAssembly changes the nature of the game. So what WebAssembly does is let unit act as a component model itself to deliver the functionality you need without the headache and overhead of going through a Kubernetes world or a Docker world or a purely componentized world, but you can still also build it locally and deliver remotely. There we go. Oops. I only pushed you once. What are you doing? So, what happens is that in a world, what happens is the byte stream of code goes across into WebAssembly. WebAssembly then sends a byte stream out to it, and that come on, let's go the right direction. I am pushing the right button for that in there. So when you started looking at web application, a web server application model, there were some interesting things. You're wanting to talk to a client, and the client has its stream of information. It's got to talk to a network layer, it's got to talk to a TLS layer, HTTP layer, and at some point way down the list, code gets executed. That code is really straightforward. Everything in the front end is something that you would rather somebody else worry about. If you're a developer, you really don't care about, you don't want to write the network layer. You assume the network layer is going to be there. The only thing you're actually really worried about is the code executing correctly. When we go into, sorry, when we go into the pieces, come on. The HTTP piece goes into it. And this thing called unit will actually handle the HTTP traffic inside of that shared block of memory. Again, singular linear memory working with the net is not necessarily the easiest thing in the world to work with. And so unit actually handles all the application execution, handles all of that networking traffic and HTTP stuff for you at the same point in time. And so, again, the only thing you have to worry about is actually writing to the code execution layer. And while unit does support multiple other languages, it's now really focused heavily on a WebAssembly world. We added WebAssembly to it in September of 2023, about the same point in time that it started stabilizing. And then when WASI Preview 2 came out, we added WASI Preview 2 to it within 1 week. That's how committed we are to this. So the unit architecture builds into it the configuration capabilities, the router capabilities. It can support applications in multiple languages. It also has reverse proxy built into it. It was actually built by the same guy who built NGINX in the first place in 2002. It also provides absolute TLS end-to-end built in. So there's no need for you to do any of the other functionalities or bring it in. It's built in as part of that structure. So in a WebAssembly world, once again, the router and the application are talking back and forth. They are sharing memory, but that memory they're sharing is not the same as the sandbox memory. And this is why we love WASI. That sandbox memory, when we're dealing with two separate linear models, meant we were passing a whole lot of memory pointers back and forth. And memory pointers being passed back and forth are not something that we really wanted to play with that much. So the context that goes into here, the WASM module, the context is passed via HTTP. HTTP then passes it off to the runtime, in this case WASM time, which executes the WASM model, which returns that information back to unit, and then sends it back to the router to send back out to wherever it was originally intended. So this communicates over that linear memory. Linear memory is not easy to work with. When we move to a WASI world, we no longer have to deal with that. We can actually deal with it from a system interface level. That makes life a lot simpler, both on us as well as improves performance. So you can try this for yourself. Unit is an open source project, and we've spent a lot of time and effort that we're looking at to do this. You can find more information about what's going on with the server-side WebAssembly. You can play with the demos and the actual working applications that are there. You can find out more about Unit itself. It's on GitHub. And on Mac, brew install NGINX unit will get you there. Now, I mentioned this, and I want to bring this forward, hopefully, at some point. Clink. There we go. WebAssembly is a standard. This is not unique to us, but we are incredibly committed to WebAssembly because it changes the nature of how applications get built. We went one too far again for this. It is part of the W3C. They define WebAssembly. Same place that does CSS, same place that does HTTP, and there's the same environments that are there. However, because of the promise of the server side, companies like Microsoft and Google and so forth built this thing called the Bytecode Alliance. And the Bytecode Alliance is bringing WASM to the cloud. Again, a server-side based model for that. And we are part of Bytecode Alliance. We have a gentleman, Oscar Spencer, who is our voting member, who is deep into this. He's been working with WebAssembly now for, I think, 6 years. And so he is quite knowledgeable and is incredibly involved in this. We are committed to this WebAssembly world because we will believe literally within the next 5 years, it will be the delivery mechanism for all of our applications, talking to the web or just living on a cloud. And likewise, Unit does it all today. You will see it start creeping into other projects from NGINX, part of F5, but it's going to continue to be there. Now, it is going to start creeping into projects. But we wanted to bring out a point here, and this is you are the people that we really want to make this clear to. We are an open source formed company. Our original project, the one that most people are aware of, NGINX, the open source server, is open source. It has continued to be open source. It was released in 2004. We may be owned by other companies, but we've also seen some changes in the open source world that we wanted to bring out here. We will not change the license. We will continue to go under open source institutes, approved licenses for our open source projects. We will not remove features from the open source technology to put them into a paid project for that. We are going to allow the community to work with us should we decide to discontinue any project. We are not just going to suddenly disappear from a project basis for this. And we will continue to be open and transparent about contributions, where they come from, and make sure that it's accessible to everybody. Over on the other side are some of our projects. NGINX open source, powering the world's internet right now. Unit, which we talked about, is an application server, but is our foray into bringing WebAssembly to production environments. We have Ingress controllers and JavaScript and other pieces that are important into this. We are, honestly, we do have projects that you have to pay for. And as part of that, what we started doing was building something called NGINX One. If you're interested in finding out more about NGINX One, stop by the booth. It's in what's called early access. And something unique is that NGINX 1 brings together both the commercial side and the open source side. If you have ever worked with NGINX itself, you will know, for instance, that configurations are the biggest headache. Anytime you have a complex product, a lot of capabilities, configurations can be a challenge. NGINX 1 has built in the ability to ship your configuration file and have it come back, do the analysis, make suggestions and improvements for you, not just commercially, but for our open source projects as well. So NGINX 1 is going to start bringing together the world so that you can actually make better use of the open source world while at the same time being able to deliver what you need to the end user environment. Again, NGINX 1 is early access. Please stop by, take a look at it. If you're working with us, open source or otherwise, it's going to make your life a lot easier. So, greater scalability, availability, better visibility. You want to know what's going on in your environment. You want to be able to monitoring and analysis work. It does all those things in there. Talk to us in the booth for that. Check out the update. Find out more about what's going on for this, and take it for a spin. So, I swear I pushed the button again. Yes. I always like to close with this quote, because as we move into a world where artificial intelligence is creeping in and making changes for us, the world is still powered by something Brian Kernighan, who helped create Unix and C back in 1979, said. Most effective debugging tool is still careful thought, coupled with judiciously placed print statements. And those print statements can come from lots of places. Our world has gotten more complex, but it's the people, you, with your thoughts, your knowledge, who are going to drive the web forward. And with that, this is me. Thanks for listening today. I'm going to give back a whole 15 minutes of time since we got a little bit of a late start for this. And if there are questions, find me at a break. I'll be at our booth. Thanks.
Thank you very much. Please stay with me here, Mr. Dave McAllister. Please stay with me here. I will give you a token appreciation. We're thankful because you want to share with us about your information. Oke? Kita minta perwakilan dari DevOps. Berikan tepuk tangan Bapak Ibu sekalian. Inilah dia Mr. Dave McAllister, Senior OSS Technologist, NGINX, part of F5. Thank you very much. Thank you. All right. Bye. All right. Please back to Yoshi. Thank you. See you again.